Hello everyone. So today we're gonna do a question on chapter 5 and chapter 2. Chapter 5 is Fundamental Frequency Estimation Method. Here is the question with a figure. So, based on the question, we need to identify the flexibility influence coefficient and the natural frequency by using Douglas method. As usual, we need to construct the free body diagram of the system with labels. And from the question, we are able to gain information on the elastic modulus, mass 1, mass 2, and the length of rod. Therefore, first, we need to identify the value of I of rod, where the diameter given is 20 mm. And by using the formula, the value of I is 7.854 times 10 power of negative 9. We learned that for simply support this shaft have the formula of Y with matrix A. Since there is 2 discs or mass, there will be 2 cases. For case 1, the value of P is assumed as 1, while P2 is 0. So P equals to 1, A 0.3, B 0.3, and X also 0.3. Since X is equals to A, we have to apply the values onto the first YX formula. So, find the A11. The value of A11 is 2.74 times 10 power of negative 4. Next, we do the same on A21. Apply the values and we get A21 equals to 1.885 times 10 power of negative 6. After that, we continue the calculation with case 2, which B equals to 1, A 0.45, B 0.15, L 0.6, and X 0.3. For this case, X is less than A. Therefore, we need to use the first YX formula. Then, find A12 and we get the values of 1.885 times 10 negative 6. Then, repeat the same steps to find A22. Here, X is equal to A. So, apply the values into the formula and we able to get 1.54 times 10 power of negative 6. Then, we arrange all the values that we get in matrix. Apply the Douglas method, which is 1 over omega 1 squared equals to A11 M1 plus A22 M2. Enter all the values. Omega 1 equals to 95.914 radian per second. Alright, finished with one question. We move to the next one. So the next question involves chapter 2. Given is the figure 6. So the question asking for I equivalent and K equivalent of the system And also we need to obtain the natural frequency of the system. As usual, first we must construct the free body diagram of the system. Well, we know that for small angle, we assume that sin theta equals to theta and cos theta equals to 1. Since this question involving rotational, so we need to change x equals to r theta and x dot equals to r theta dot, and also x double dot equals to r theta double dot. Also, list out the I formula. Moving on to step 1, which we need to find the summation of force for mass 2. And we get the value of T2. Then we label this equation as equation 1. Next, do the summation of moment and gain equation 2. Next, do the summation of force for mass 1, and we able to get the negative T1 equation, which is labeled as equation 3. After all that, substitute the equation 1 and 2 into the equation 3. And of course, we're able to acquire the equation of motion. So, the M equivalent is, and thus, we can find the natural frequency, which is omega n equals to Z K equivalent over M equivalent.